Good morning. How's everybody doing today? Awesome. So we have a full talk today. It's very packed. We're going to cover some very interesting topics. So I'm Allan Naim. I work on Google Kubernetes Engine at Google. I'm part of the product management team there. And I am joined today by Wei Deng, who is VP of Product at StackRox. So StackRox provides container security. It is one of the options that's available when you're running Google Kubernetes Engine. And we're also joined by Alex van Boxel, who is a cloud architect at Venti Exclusive. And then Connor Gilbert with StackRox will actually be wrapping up our talk today with a really, really cool demo. So really looking forward to that. So let me frame the conversation before we dive into things. The talk is called GKE Architecture Patterns for Retail and Financial Services. And I bet you're asking why retail, why financial services? What is the similarity here? Why are we talking about these two industries together? And the reason for that is, from an executive priority standpoint, there are similarities in terms of what these two industries are really trying to achieve. Although from a regulatory standpoint, it's very different, right, in terms of the challenges that you face from a financial services standpoint versus retail. From an executive priority standpoint, some of the commonalities include, your data is your most important asset, right, in both industries. And the two industries are really transforming as well, right? Retailers, whether it's brick and mortar or e-commerce, are becoming software companies in many ways, right? The need to be able to deliver software quickly and push that software to the edges and transform that customer experience in real time is crucial, is really crucial to competing. And both industries are really in the midst of this. With the advent of open source technologies, in particular containerization from several years ago, right? It's presented a way for companies within these verticals to really be an internet scale company and figure out ways to really bring the experience to the user as efficiently and quickly as possible. And that's all, a lot of it is software. How do you build that software to enable that and make that happen? Right? Our customers are becoming smarter and smarter, right? There are so many signals associated with customers that you need to keep track of and be aware of in terms of tailoring that experience for your customers. At the same time, this is a study that was done very recently. 75% of customers out there expect a consistent experience in terms of dealing with the institutions, right? Whether it's mobile, whether it's online, whether it's going in to the brick and mortar location or a banking center. At the same time, 64% of consumers expect that organizations will respond and interact with them in real time. We live in a society where people really have no patience. You want response immediately, and you want that response to be continuous. And then 2/3 of consumers will actually switch brands if they're treated as numbers instead of individuals. So you have to tailor that experience for that customer. And how do you do that? Again, using software. So just a show of hands, how many people here are actually running containers in production? Very cool. How about using Kubernetes? And using Kubernetes on Google Cloud, Kubernetes Engine. It's fantastic. And then how many developers here? Okay, great. This is a great composition. So the technology impact is really transforming how people do things today. And a lot of it has really been being pushed by containerization, by efficiencies around continuous integration and continuous delivery, as well as machine learning that's really bringing a facet in terms of how you make decisions and bringing the cloud into a lot of this workflow. And for companies that are really at the midst of this today, and in particular, I'm seeing this a lot with retail and financial services, there's only two ways that you can go, right? At the end of the day, we all want to get to that top right corner, but it's either up or out. And really, the up path is taking what you have today in your data centers and modernizing it, right? a lot of companies that I talk to are actually building PaaSes on top of their existing infrastructure because they want that speed, that agility. On the other hand, you can move to the cloud, lift and shift, and then modernize when you're in the cloud. So we see both of these trends that are happening, but eventually, we all want to get to that top right quadrant, and there's always going to be a component that's sitting, whether it's on-premises or multi-cloud, but you want to be able to manage these investments in a consistent fashion. So from an internet scale application architecture, at the end of the day, we all want to be able to push releases, n number of times each night. We want to be able to build applications that are coherently resilient and scale really well without having to worry about the underlying infrastructure. But as a developer, all you really want to care about is your application, right? You really don't want to care about the underlying mechanisms like your networking, your load balance, your health checks, how you implement that resilient architecture. Of course it's important, but you really want to focus on the application and then let the underlying framework really do a lot of the heavy lifting to abstract away the complexities for that application, underneath that application. And really, that's where Kubernetes came into the picture. Containers solve a very important problem, right? In terms of how do you package up an application, make it portable, run it in such a way where you're taking all these various dependencies and you have really a predictable way of running that application across different environments. But then it introduces a lot of complexities, such as how do you scale these applications? How do you run these containers across a pool of compute? Containers are ephemeral. How do you mount storage to these containers and ensure that you can run not just 12-factor stateless applications, but stateful applications as well? How do you do that in a consistent fashion? What about day two type models around operations, monitoring, logging? How do you expose containers to the outside world so that they can be consumed by external applications? Those are the kinds of things that Kubernetes really helps solve. And Google has had a managed Kubernetes offering for the last 3 years. It went GA, general availability, 3 years ago, called Google Kubernetes Engine, which is a managed service around Kubernetes that basically makes the cluster creation process an API call. You specify how many nodes you want, where you want your nodes to live, the type of resiliency and highly available infrastructure that you want underneath your cluster, and then you're in business. You've got an API, a command line interface that you can now use to deploy and run your applications. So what I wanted to do now is, I can sit here and talk and explain all the various great things about Google Kubernetes Engine and Kubernetes and so forth, but I feel like it would be tremendously more valuable for you to hear it directly from our customers and our partners. So first thing I'm going to do is I'm going to invite Alex to come and talk about how Google Kubernetes Engine actually enabled them to become more agile and move to microservice architecture and all of the challenges that they faced going down that journey. And then we're going to have Wei bring a different perspective. As a technology partner, they offer a solution that actually helps customers really build secure environments. I mentioned the important thing is ensuring your data is safe. Well, Wei's going to bring a different perspective around what are some of the patterns that you should be implementing to ensure that your environment, container environment, is protected and secured, and then we'll show you a demo around that. So without any further ado, Alex, the floor is yours.
Thank you, Allan. So I'm Alex. I'm a cloud architect. So in a company at our country and size, that means you also have to get your hands dirty. And you also code. So, but let me first present Font Exclusive, not like it's French named, so it's Font Exclusive. Font Exclusive is in a special kind of e-commerce business, and it's the flash sales. What does that mean? It's like we have every day 100 sales open and they close. Each day we have opening and closing sales. On average, a sale is open for around a week. As soon as that sale closes, the goods are ordered with the suppliers and shipped to our customers. So it's not the next day delivery in general. So about 2 years ago, we've been acquired by a bigger company, and that acquisition actually brought some special things. We could like operate the northern of Europe. It's like it was a French company that acquired us, so that means everything above France. And that acquisition brought some like special cases for us, because we were normally operating in a small part of Europe, and we're running a monolith. And going to the northern of Europe, that means like more countries with special business needs, more languages, and other currencies. Not all of Europe is running the euro. So with that, we said we're going to develop the platform of the future and go for microservices. Running a monolith for 10 years brought some extra advantages. We actually knew our business quite well. So we put silos in our architecture. That was like the shop, the warehouse, data. And within those silos, everybody could make their microservices on a certain use case or domain. The technology that could be used there could be really tailored to the use case or the competence of the team. As we were quite mainly a .NET company, most of our services were created in .NET. But like in the data team with data scientists, Python is more in their skill set. So there it turned out that we had like a lot of Python code and even Go if we really needed to have performance. The databases, that was also the choice of the best use case. So it could be relational or non-relational. It didn't matter, they had their own choice, but a very important thing is that each microservice is like is data separated. So a very good isolation between them. And at the time, so we started like more than a year ago to re-platforming. And why did we pick Kubernetes? Well, because at the time that we chose, till Kubernetes came along and Docker came along, containerization was really a technical thing, and Kubernetes was the first orchestrator that actually brought some concepts that a human could understand. And luckily, we were already on Google with our data platform, so we actually tried out GKE. We also asked for an offer at our current hosting provider, but by the time that they came with a real offer, we were already running some stuff on GKE. But going to microservices brings some extra challenges. So it's more than 3, but I picked 3 of my favorite ones. It's like the developer experience, observability, and also the data silos. Developer experience. So if you're used to creating a monolith and then have to go to make very big blocks, you have to make sure that developers don't lose speed. So in the beginning, we did a lot of small things and make sure that the development speed didn't go too low. So the first thing was like access control. Luckily, Google had like the Google accounts that we really could sync with our on-premise Active Directory, and it was with just a snap they have access to the cluster. And with those Google accounts, they also have like access to services like logging, tracing, and even if they needed BigQuery, they could have access to BigQuery. Another thing that is very important, and helped us really in the beginning, was make sure that you have a set of guidelines between the teams. It's very important. One of them is like, make sure that your microservice has a single name. You could have like some silly names like port porting, or is it back office reporting? But the thing is that it really helps with automating the process. So with like conventions, when there was API at the back, then we automatically expose that to the outside world. Was it a batch? Then it was a batch system. It really helps to just make the developer flow go well. Another thing is make sure that you have contracts defined between the microservices. We actually learned the hard way that going code first is not the best approach. So we actually slowly moving now to a contract first, where we are slowly moving to gRPC. And with some cool tools like cloud endpoints and probably Istio as well, it eases the way because it can expose your gRPC interfaces as REST as well. Then don't forget this. Continuous deployment. Start in the beginning. All those conventions and so on really help automate the process, the automation processes, but make sure that those automation processes are all centered around the continuous deployment pipeline. We chose GitLab because it is a nice combination with Git repos and deployment pipelines, and it has nice tools for code reviews as well. We are now going to the next level, and with the evolution of Kubernetes, with the custom resource definitions, we are going for a GitOps approach, where everything, the desired state is in Git itself. Next, observability. As everything is like scattered around, make sure that your system is observable. Like in a single application, it's a bit simpler, but luckily, Google has a Stackdriver suite. You probably saw it yesterday, that there were some nice announcements here, but so that's very good. So at every microservice, for us, we had like the cloud endpoints, but now with Istio, probably you want to go to Istio, but we have been running this for a year, and cloud endpoints really helped us to make it observable. Because having actually a proxy just in front of your microservice makes sure that everything is logged and traced, and that really helps. Those logs and so are aggregated with everything in the Google ecosystem. So everything what comes in the network and even your Kubernetes cluster all come together in the same logging system, and it really helps dive deep. But don't forget, make sure that you have like special log entry points, trace points, and metrics as well in your application. Because an example of a metric is like active cars, for example. And through the Stackdriver suite, it all merges the operational logs and your custom metrics together to have a deep dive. And if you want to be an observer superstar, make sure to export all your logs to BigQuery. I find it quite strange that not a lot of people do that, but it's just a click away. And now it's the time to go to Istio, look at that one. We work on cloud endpoints because we started very early. Make sure to look at Istio, and also make sure to look at open census. With that, you get like nice dashboards. Now with the announcement from yesterday, you also have service graphs added on top of it. And that's very important if you want to dig deep, if you have troubles in your system. And the last, but this is my favorite one, is how to get the flow of your data in your system. So everybody knows the typical use case of sync calls, where microservice A calls B and C. But make sure to go for an async approach as well, where you actually put everything on PubSub. PubSub is also a good technology of Google, where you just can publish your entities, and that makes it possible for other microservices to subscribe there. An example is when a cart is complete, your logistic process could listen on those events and trigger the slow flows. And with the added value, if you do it consistently over all your microservices, you could listen there in your data lake on all those topics and combine everything into BigQuery, Bigtable, or Elastic, or whatever technology you choose. And that's a way where you actually break the barriers between those silos. And then your data analysts, your marketeers, really have one tool to query over everything. And that's then BigQuery. And it combines with, you have some nice dashboarding tools like Tableau, where you can have back a view on the business. So in hindsight, going to Kubernetes Engine was really a lifesaver, because then we could focus on those problems. But because like having a managed service is not just running Kubernetes on a few VMs. No, it brings autoscaler, auto repair, monitoring, all out of the box. And with the 3-monthly release cycle of Kubernetes, the newest version of Kubernetes is just a click away. Like I do an upgrade of the cluster to a new version in a meeting. So lessons learned, make sure to have like conventions, contracts, and automation in place. That will help you accelerate your developers. If you don't have those things, you could be up for some chaos. And embrace eventual consistency through PubSub, where you publish every entity in there and listen there in your data lake and put it in BigQuery. And make your system observable, certainly with the nice tools announced yesterday. This will be great. So that's it for me. Wait, it's up to you. Thank you.
My name is Wei-Lian Deng. I am VP of Product at StackRox. StackRox is a Bay Area-based startup that delivers cloud-native security for the Global 2000. Our product is a platform that secures containers and microservices across their entire lifecycle, from build to runtime. We're pleased to be a Google Cloud partner and jointly working with some of the world's most recognizable enterprises across technology, media, government, and financial services. This morning, I'll share about our collaboration with financial organizations, a collaboration that has enabled them to modernize their infrastructure and app architectures atop Kubernetes and GKE. And one of the primary challenges that these customers face when moving to GKE is thinking through how to effectively leverage a shared security model, which requires considering what controls do you need to implement on a standalone basis versus where do you need to augment existing controls that are provided by GKE. And our customers tend to hone in on the following concerns. The first is, can strong security boundaries be established to isolate and segregate containerized workloads? Isolation needs to extend across pods and services, nodes and clusters, and so on. Second, what is needed to ensure that the container software supply chain, which generates the images used to instantiate containers, remains under the customer's control? You need continuous verification, attestation, and auditability. And finally, this customer segment has to tackle regulatory compliance in a context where requirements for containers specifically are not yet that well defined. And so relevant certifications and data protection requirements are going to vary across workloads, of course, but what we tend to see is that financial customers take conservative interpretations of existing requirements, map them to container environments, and also increasingly adhere to guidance on container security that has been published by organizations such as NIST and the Center for Internet Security. I'm excited this morning to share 3 examples of how the combination of GKE and StackRox together has successfully enabled enterprises to navigate these concerns. In the first example, we've worked with a Fortune 100 bank. That bank has a line of business that's leading the bank's digital transformation efforts to reimagine the consumer experience. And to do that, they've built an entirely new investment management application that runs on hundreds of nodes in GKE. In the second example, a Fortune 50 financial services firm, runs containerized analytics services on dozens of nodes in GKE on demand to better leverage data that has already been warehoused in GCP, thereby driving greater ROI. And in the third example, a Global 200 enterprise has re-architected its SaaS e-commerce platform, a platform that serves small and medium-sized businesses by providing them with everything from a storefront to billing and order processing functions. They've re-architected that platform atop Kubernetes. They run it on premises today with a plan to move it into Google Cloud, and it's designed to scale to thousands of nodes across dozens of clusters. Now, Alex talked a lot about infrastructure modernization, and at the same time these businesses selected GKE and Kubernetes to drive that modernization, they also had to figure out how to address the unique security challenges that were introduced by containers. Existing security tools lack container awareness and are rendered obsolete. The attack surface expands beyond just containers themselves to encompass layers that include the container runtime, the orchestrator, namely Kubernetes, the registry, and so on. And so there's the emergence of new threat vectors that need to be protected against. And then finally, the short ephemeral lifetimes of containers make necessary functions such as auditing, response, and forensics in particular much, much harder. And so to solve these challenges requires modernizing security as well. And there are a lot of great talks going on this week about security for Kubernetes and GKE. I encourage you to check out those talks. What stands out is how Kubernetes is modernizing security with the breadth of baseline capabilities that are being built into the platform itself. There's firewalling for pods and services. There's TLS throughout the cluster. There's access control and audit logging and secrets management and storage on the master. GKE takes all of this, operationalizes it for you, and augments it by giving you a minimal container-optimized operating system, by managing the master for you, and also integrating with container analysis and image scanning functionality that's part of Google Container Registry. And so where a customer previously had to turn to several standalone security tools to implement all these controls, they can now benefit from a single infrastructure platform that makes security fully programmable. But our customers, particularly those in financial space, still require more. The move to containers does not obviate the need for security functions like vulnerability management, configuration monitoring, compliance, policy enforcement, threat detection, and instant response. These customers look to standalone solutions like StackRox to solve for these use cases. And so what StackRox does is unify this set of capabilities into a single platform that allows our customers to run on GKE with high assurance and confidence. I'm not going to run through some of the common architectural patterns that we've seen among our financial customers adopting GKE. And so in the first example, that Fortune 100 bank chose to build a new cloud-native mobile-first application on top of GKE. And what that looks like is there's a highly scalable web tier made up of microservices that sits behind a GCP load balancer and a reverse proxy. There's a separate set of microservices that handles brokerage functions, order processing, reconciliation, and other tasks. And that tier interfaces directly with data that is persisted off cluster and is non-containerized. Everything that runs within the cluster is stateless. The tier also interfaces with a set of internal custodial services as well as third-party APIs. And one particular concern of this customer was that an attacker could potentially gain a foothold somewhere in the web tier and then subsequently move laterally from one service to another to gain access to the brokerage tier, which would then give that person access to the data or other non-containerized bank services. And so the ability to detect and respond to that type of threat vector is one of the main use cases that StackRox has helped solve for that customer. In the second example, that Fortune 50 financial services firm has already been using BigQuery and Cloud Data Flow to set up a highly efficient data pipeline that handles transformation, batch processing, and warehousing. And what they've added on is a GKE environment that allows their developers to spin up containerized Spark applications, and that those Spark applications can be used to process the data that's already in BigQuery or analyze it or query it and manipulate it. And GKE makes BigQuery integration extremely easy, literally via a drop-down selection in the console. And because those Spark services run on demand for limited periods of time, understanding what is running, what has already run, and how policies are enforced on services that are processing different data sets with varying degrees of sensitivity becomes a very hard challenge. And so that is one of the main areas that StackRox has helped solve for them as well. And then finally, that Global 200 business that has containerized its existing e-commerce platform on premises. This is really an effort designed to drive application portability and agility, and is part of a plan to eventually move to Google Cloud and GKE as part of a broader lift and shift migration. Now, what stands out here is that these are not microservices. These are legacy services. Think Tomcat, think WebLogic. These are not stripped-down services built from minimal base OS images. And so vulnerability management and configuration, handling misconfigurations and compliance become critical use cases that the customer and us initially focused on. Separate services are run to handle logging and monitoring. These are off-cluster, these are non-containerized, but as part of the organization's move to GKE, they anticipate adopting the Stack driver seat, which Alex described, for those functions. As a proud partner of Google Cloud, we've invested in delivering a seamless experience across StackRox and GKE. We have a native integration that automatically sends alert information out to Cloud Security Command Center so that you can view threat information about your containers alongside all of your other security data about all your other cloud resources. And I'll also reemphasize for a moment the importance and significance of discovery and gaining visibility when migrating to GKE. It is the starting point for nearly all of the financial customers that we engage with, being able to understand what is running, what has run, and to do so in a context that abstracts away potentially thousands and thousands of containers. Security operators do not want to immediately know what is going on with each and every single container. Rather, they need to be made aware of whether there's been a particular incident or threat on a given application. And one of the unique ways that we provide comprehensive visibility for customers is we interface with every key layer of the full container stack. And so we interface with the operating system, the runtime, the orchestrator, the registry, and so on, so that we help build a bigger picture and deeper picture of how your GKE environment is changing over time. So what have we gleaned from the past several years of working with the financial services community? Here are some common practices that we see nearly all adhere to. The first is they start with hardening their cluster infrastructure, utilizing controls that are built into Kubernetes and GKE, such as role-based access control, node constraints, service count privileges, network policies, metadata concealment, and so on. It's a very long list which speaks to the richness of security capabilities that are being built into the platform itself. Next, they focus on ensuring that their images are securely built and secure to use, that they meet best practices, and that the runtime environment is configured against known benchmarks. Automation is key here. Automation and programmability, the same principles that are driving infrastructure modernization, also have to extend to security. And finally, they then focus on analyzing container activity. Once your containers are running, you can actually analyze their behavior to better identify threats, because the declarative and immutable attributes of containers make it easier to spot when an attacker is potentially looking to gain a foothold, escalate privileges, persist within the environment, move laterally across services, or achieve some type of objective such as crypto mining or exfiltrating data. And regardless of where your organization is on its container journey, here are a set of key lessons from our customer success stories that you can act on today. The first is that the security controls that are built into Kubernetes and GKE provide the starting point for any comprehensive security program. Identify what else is needed, where, to then solve for additional use cases such as threat detection and response. Build in automation and apply automation, fast iteration, and closer collaboration between security and DevOps teams as part of your organizational workflows to better prevent, detect, and respond to threats. And then finally, tune your security policies based on the rich context about containers that can be gathered via declarative metadata and runtime configuration. Collectively, these lessons have helped our customers and can also help you to better harness all the advantages that Kubernetes and GKE have to offer. We're now excited to show you how this all comes together. I'd like to invite Connor on stage, and he's going to demo and walk you through 3 examples of how GKE and StackRox together help protect against a set of threats in a live GKE environment.
Thanks, Wei. I'm Connor. I'm excited to show you a live GKE cluster, as Wei mentioned, and demo 3 real-world scenarios of container security. I could talk to you about this for hours, especially about how much container technologies, Kubernetes, and the integrations with Google products can really help you get all the right visibility in the right places, but I have about 5 minutes, so I'm going to dive right in. Okay, so I'm going to show you these 3 scenarios. They're based on exposures at Tesla, Shopify, and inspired by the Equifax attack. I don't think they were using GKE. So on the screen, you've got a StackRox portal running on the left-hand side and the terminal that I'll be using on the right. So let's start with the Tesla example. So this is an example where there was an operational mistake or a cluster misconfiguration, and that led to a cryptojacking attack discovered by a security firm who was just scanning the internet for Kubernetes dashboards. So first, we're going to expose the dashboard here. The Kubernetes dashboard service it can be helpful for debugging, but it can be a security exposure. It doesn't run with a publicly trusted cert, so I'm just going to click through. And you can see you can log in with a kubeconfig or a token if you're going to use your privileges and just proxy to the API. But you can also skip. And if you do skip, it's going to use the default service account that the dashboard service is running under. Now you can see there are all these errors. You were trying to debug something, and now your screen is just full of errors. You're supposed to be fixing these, not getting more. So you Google this, you find out, okay, this user account cannot list persistent volume claims. And you'll find some YAMLs and some instructions about how to give that service account cluster admin access. And this is actually, I believe, what happened in that Tesla example. So I'll go ahead and elevate permissions for that dashboard service account. And if I refresh the page, I can see everything. I can debug my problem. And then I go away, and I forget to take it off. So now anyone who goes to this node port address will be able to come in and use this helpful create button that is up in the right-hand corner, where I can create deployments. So I'm going to just go ahead and create a YAML, create a deployment. It is running a crypto mining service, and upload, and there we go. I'm going to head back to the dashboard and show you that we will have detected a new service coming up, and then the crypto miner being run. Wei talked about software supply chain and what's in your images and everything, but sometimes you do need to know what is actually happening. Because I just introduced an image from a publicly available registry that wasn't the one that you were using, so you wouldn't have any sort of scan data or anything. You can see there's an error. I'm running minord inside that process, all the metadata that you'd need to go respond to that issue. Okay, so now I'm going to continue on. The countermeasure here is really like, don't do this. It's easy to make these mistakes, and the defaults are getting better, but you might have an old cluster, and it's really important to audit who has cluster admin and the exposure of important services, especially out of that kube system namespace. You can even disable the dashboard entirely in recent GKE releases. All right, we'll move on to Shopify now. So I just first want to give credit to Shopify for helping educate the community about this kind of issue. They posted this as a bug bounty on HackerOne and made it publicly accessible so that everyone can learn from what happened to them. So let's move on to that demonstration. The vulnerability there was that they had a service that was vulnerable to server-side request forgery. You could ask it to make network requests, and those network requests could include internal resources and sensitive things like the cloud provider metadata server that's running on every node. So I'm going to start by just deploying an application that's sort of trivially vulnerable to server-side request forgery. And the first thing I'll do is have it just check what IP it's running on. So you can see first I'll show my laptop IP, and then we should be able to see the IP that the container cluster is actually running under. So there's my laptop, and then this is actually the container node that the container is getting egress from. So you can tell they're different. All right, so then that's not super interesting, but what is starting to use the orchestrator against itself. So you can, if you make this kind of request, you can talk to like the local kubelet read-only API and enumerate things about the cluster that you're in. So for instance, I've just gone and enumerated the images that are running on this machine. And this actually highlights the importance of segmentation and separating sensitive workloads that was mentioned earlier. You can use built-in Kubernetes features that are fully available in GKE to make separate node pools for sensitive data, apply taints and tolerations. So you taint a node and then tolerate it in the workload. And you can say that only sensitive things can schedule on these sets of nodes so that nothing like my dumb little app can be scheduled next to your sensitive data and then be used to steal it. And so that's an example of using the kubelet API against the cluster. The other example specifically to Shopify was using the kubeenv. So you can see there's a bunch of stuff here. Not all of it immediately decipherable, but eventually the bug report includes the fact that there's a key and a certificate that can be used for TLS bootstrapping with the kubelet. This is another thing where GKE has a countermeasure, but it wasn't enabled. So there's a feature called metadata concealment, and there are long-term plans to distribute cluster metadata more securely. But you just need to opt into that kind of concealment to stop this kind of attack. You can see on the left, we're monitoring for things like cloud metadata access. So this container ended up contacting the cloud metadata server, and that is not in its sort of normal behavior, and so we've alerted. I'm going to move on now to the Equifax attack. I'll highlight this is inspired by, but not an exact reproduction. I don't think they were using containers, and I don't think they were using GKE. But it's an example of where application vulnerabilities really can hit you, even though you're in containers. Containers have all these rich configuration options, running as different users, running with read-only rootfs, abstracting away the access to secret things, abstracting storage away from you. But you can still write an app that gives people access and have not configured the security boundaries well enough that they can keep going. Okay, so I'm going to deploy an app that is vulnerable to a struts CVE that allows remote command execution. So that's created, and I've created a sensitive database service that I'll then contact. So I'm going to go ahead and just make a crafted HTTP request that injects a command and connects to that database and dumps some information about it. The database is the tables inside. So the port forward is still going to do this live. So we got to pull the pods. Okay, now I'm going to start again. Okay, so you can see the data leak here. So we're able to make this large, exciting crafted HTTP request that included some MySQL commands. And then the output was all the databases in the database and then all the tables. And if there were more stuff in there, you could have executed commands like that also. And you can see on the left-hand side, we've alerted on a lateral movement because these services don't typically talk in this manner. So just an example of runtime monitoring of those connectivity graphs and to catch the lateral movement once they've gotten in on the initial foothold. They're trying to get the objectives. They're trying to get your data. They're trying to get the things that they want. All right, so I'm going to hand it back to Allan after this. I'm excited to have shown you 3 real-world scenarios in a GKE environment and the way that both GKE defaults and StackRock's type protection can help secure your workloads. Thanks.
So call to action. We covered a lot of topics today, and there's a whole bunch of sessions that are going on at Next that go really deep into various areas. Yesterday, there was actually a great session one of our PMs delivered around Kubernetes and enterprise security requirements. It's all going to be available on YouTube. And then today, there's a bunch of sessions, one on containers and Kubernetes Engine that really goes deep into some of the differentiators with Google Kubernetes Engine. And then later on in the afternoon, there's a session on the best practices from Google SRE. I highly recommend checking that out. It's going to be really a combination of both GKE and Istio. And then there's a session later in the afternoon really around running managed Kubernetes both in a GKE perspective, but from a multi-cloud standpoint. So for those of you that were in the keynote yesterday, you probably heard the announcement around GKE and the on-prem component. So it's going to get really interesting in terms of providing that consistent experience for managing your applications in a hybrid fashion. So with that, thank you very much for your time. Really appreciate it. And I wanted to thank the speakers, Wei, Alex, and Connor. Very nicely done. We'll take a few questions. So if you do have questions, please walk over to the podium and ask away. Thank you.